Hello everyone, welcome back to my YouTube channel. So in this video we are going to discuss about HELM. So basically HELM is a package manager to deploy or manage your Kubernetes resources. So in Linux operating systems we have seen suppose if we have to install any application or any package, then what we do, we simply write a command called sudo apt get install and maybe Apache. In that case apt is a package manager, which is the full form is advanced package tool. What it does, basically somebody is already write a configuration to install and configure Apache servers. We are just simply going to use that particular package from the repositories, and we are going to install in our local system or in basically in our servers. Same concept here we have with HELM as well. So HELM is also a package manager tool which use a public repositories. For example, Bitnami. Bitnami is a public HELM repo and most popular repositories as well, where somebody is already write down the packages. For example, if we have to install a Nginx application on Kubernetes, what we can do, either we will write a manifest file to deploy Nginx applications, or another option what we can do, somebody's already created up to the created a package or manifest file to deploy a Nginx applications. So what we can do, basically we can simply go to HELM public repo and we can download the package from there, and we can install Nginx application on our Kubernetes clusters. So that's how basically we use HELM. Now the question is, why we need a HELM? What is the requirement to use a HELM? So let's understand in more details. Okay, so in general, when we need to deploy any resources or any application on Kubernetes, the first thing what we do, we write a ML manifest file. For example, suppose I need to again deploy any suppose Nginx applications we are going to deploy. So what we will do, we will write a deployment manifest file. Then we will write a service manifest file because we want to access the application outside the Kubernetes clusters, so the service manifest file is required. Then maybe we need to create a volume, and then we need to maybe create a secrets and a lot of other stuff as well. So in that case, to deploy a single Nginx application on single environment, we are going to write multiple ML files. Suppose we have four environments basically. Now for one environment, if we are going to write 5 manifest files, then 4 environments we are going to write 20 manifest file. In that case, what is happening, we are having a multiple ML files. This is a very simple example which I have given, but in real time or in production level, you will have maybe 15 to 20 ML files to manage resources on Kubernetes clusters or deploy the resources on Kubernetes clusters for single environment. So this is going to a very complicated to manage those ML files. So to resolve this, what we can do, we can use a HELM charts. Okay, now the question is, okay, we can manage the ML files maybe a 20 or 30, but if it is going to be 1,000 of ML files, then how you are going to manage? So that is a very challenging options or a challenging thing basically to manage. So we will use a HELM chart to resolve this. What you are going to achieve with HELM and what you are not going to achieve if you are not going to use HELM. So here I have taken one example here. Let me go to another slides. Okay, so suppose we have 3 environments: deployment, staging and production. Now in this deployment, suppose for development environment we need a 1 instance of our application. For staging we need a 3 instance, production we need a 5 instance. Then the image name is also going to change based on the environments, and here as well, and the URL is also going to change. Now these are the values which we are going to change in multiple files if we are not going to use ML files. So again, this is a very time consuming process because you have to go to each manifest file and you have to update those values, right? But if you are going to use HELM, then what you will do, you will create a Helm charts. I will come to Helm charts in a meanwhile. And then we are going to create a values.ml file where we are going to declare all these things. So instead of going to multiple files and changing these values, what you can do, you can simply go to a one particular file and you can change the value. So which option is easy to modify multiple files or to modify a single files? So this is the major difference when you are not going to use Helm as a package manager to deploy or manage your Kubernetes resources. So that's why in real time or in production level, we use a Helm to manage or to deploy our resources on Kubernetes clusters, because it makes things easy for us, because we are not going to manage multiple manifest files. Maybe we are going to manage a few manifest files, because most of the times we are going to create a templates, and those templates will remain same across the environment, the deployment, staging, productions. Just we are going to change the values based on the environment, right? So this is the benefit you will get when you are going to use Helm. And there are chances also where while we are updating manifest files, maybe we can make some mistakes. Because of that, our applications will face a downtime as well. So it will avoid human error as well. Okay, so the solution is Helm. So here, instead of managing separate files for each environments, we will create a Helm charts. Under Helm charts, we can manage or deploy our deployment services, config maps, and a lot of other stuff as well. So this is the benefit of using Helm. Now let's understand what is Helm chart, because this is the heart of Helm. Because here we are going to manage everything which we are going to deploy on our Kubernetes clusters. So Helm chart is a package that bundles together all the necessary resources and configurations for deploying an application or services on Kubernetes clusters. So basically, Helm chart is a package which will contain all your manifest files which you are going to deploy on Kubernetes clusters. So what you will do, you will create a Helm charts, and you can simply run a command called helm install and the chart name, and it will deploy all of your resources on Kubernetes clusters. So this is very simple. Instead of running multiple times one by one, that is very time consuming, and it will take a lot of effort as well to manage those files. But Helm charts is save a time for us as well. It will very easy to manage the resources for our application as well. So what you will do, there are basically three important files in under Helm charts. So the very first is chart.ml, another file you will see values.ml, and third file you will see a templates. So under charts.ml file, basically we will specify or we will write our metadata, maybe a name of the application, version, and maybe a brief descriptions about the chart or maybe applications. Then another file we will have a values.ml file. So this is the file where we are going to pass all the values like number of replicas and the image name, so URL. So a lot of stuffs we are going to manage as part of this files. And templates basically will be a manifest file, the actual code of your application to or deploy your application. So actual manifest file we will create inside a templates, and those files will be parameterized, or we will create a variables, we will declare a variables, and those variable value we will pass in values.ml files. So these manifest file will remain same across multiple environments. Just the values.ml file is going to change based on the environments where you are going to deploy your applications. So in this case, what you are going to majorly manage this file. So suppose I have to deploy nginx application on dev environment. We will use a manifest file from this template folder, and during the runtime we can pass the file where we have dev environment values. So this file is very important because from this file we are going to manage or deploy the resources. So this is the benefit of using Helm. Now another thing is repository. So Helm repository is a collection of publicly available Helm charts. So Helm charts are your manifest file basically. So suppose I have to deploy nginx application on my Kubernetes cluster. So there are two ways. Either I can write a manifest file from my own and deploy the nginx applications. Another option, somebody is already written the manifest files and they have published on a publicly available Helm repositories, which is Bitnami. So this is the very most popular Helm repo, and we are going to see this repo in our demonstration as well. So in this repository, most of the charts or most of the manifest file which you will require to deploy your application or resources on Kubernetes, you can find it here. So what you can do, you can simply download nginx application from this public repositories and you can customize it based on your requirement and you can deploy your applications. So here basically you are going to save a time to write a manifest file. What you are going to do, you are simply downloading the already available manifest file and you are just modifying based on your requirement and you are simply deploying it. So which option is very feasible? Either you will write from scratch to end and or maybe because we are not going to write a single manifest file for applications, we will deploy deployment and manifest file, then we will deploy service, then maybe secrets, volumes. So a lot of files basically we are going to write. But if we are going to use Bitnami or maybe Helm repositories, then we already have those files. Just we are going to modify those publicly available manifest file based on our need and we are going to use it. So similar things, example here I have given, say like when we need any applications, what we will do, we will simply go to our Play Store or App Store and we can download the application and use it. So same concept here we have is repositories as well. Another option is, or sorry, not option, another core component of Helm chart is release. So release is a basically running instance of your application, or I would say running instance of your chart on Kubernetes cluster is called a release. So suppose I have deployed nginx applications. So when we deploy or when we install any Helm chart on Kubernetes cluster, that deployment is called a release. So we will not say deployment, we will call in Helm as a release. So your running instance of your chart on Kubernetes cluster is called a release. And you can when you install any Helm charts, you can give any unique name as well, maybe release 1, release 2, release 3, release 4. So you can simply track all your deployment, like which version you have deployed and what all the things you have modified based on this deployment. So everything you manage and track whatever you deploy on Kubernetes using Helm. Now what you have to do, simply you have to go to public repo, you have to grab the chart from the repositories and simply install it as a release in your Kubernetes clusters. This is very simple and straightforward process to deploy any Helm charts on Kubernetes clusters. So we are going to see all those things in a demonstration part, but for this video I just want to brief you about Helm and its core components and why we should use Helm instead of multiple ML files. So next video what we are going to do, we are going to set up a local environment using Docker desktop and we are going to enable a Kubernetes cluster on that, and then we will install a Helm and we will simply deploy any sample Helm charts on our Kubernetes clusters. So I hope it's clear. In case if you have any doubts, you can definitely ping me over comments box. So that's all for today. See you in next video. Thank you so much.